Uh, Hi everyone, we are back with a new problem of TSA. So last time we did the problem of linked list. So this time we are going to do the problem of tree, the binary tree. So today the problem is some root to leaf numbers. This is problem number 129 and it is of medium level of lead code. So the problem is something like that. You were given a root of a binary tree containing digits from 0 to 9. Only each root to leaf path history represents. Suppose, for example, the root to leaf path is 121, 2, 3, represent the number 123. So the problem is something like that. Suppose we are given with this tree and we have to add these number up to leaf node. Suppose from here to here the leaf node is 1 and 2. So the number will become 12 and here the number will become 13 and we finally add up this number and the result will be 25. So let's see another example. Here from here to this leaf node the number will become 495 and again from here to this leaf node it will become 491 and from here to here it will become 40. So the answer will be 490 plus 495 plus 491 plus 40 equals to 1026. So I hope the question is clear to you all. Now came to the logic part, that how we're going to implement, how we're going to write the code. So first let us understand the logic. So suppose we were given with this tree. So I'm taking another color. Now what we will do, initially we take one variable because we will going to implement the loop answer, which is going to hold our answer, and initially it is equals to 0. Since we have to form a number from this root node to leaf node, this means that the condition of leaf node will going to apply, and the condition of leaf node is, suppose we are going to okay, I was telling the condition of leaf node. So the condition of leaf node, as we discussed earlier also, it is the node at which left child is also none and the right child also none. So we check at every point that if root dot left equals to null and root dot right equals to null, or we say none in Python. So okay, now how we will going to implement it? Let us understand. Suppose we start from this root node. So here the answer is 0. So we will put answer equals to answer into 10 plus this value, means plus root dot well. Now how will it form the number? Let's check. Suppose we start from 1. So answer initially is 0. So answer holds the number 1. So answer will become 1 over here. ANS equals to 1. Now we will traverse from left, from this root to left side. We came over here. Again we will check that if this the left side and right child is none. No, the condition gets false. So again it will call this line. So this time, since the answer is already 1, so ANS into 10. So 1 into 10 is 1 into 10 equals to 10. 10 plus 2 equals to 12. So now this time answer will become 12. So again it will go on left side and check 4. Okay, now it get 4 and the left and right is none. But before that, this line will get implemented. So it will add like this. 12 into 10 is 120. 120 plus 4 equals to 124. And finally, since left and right both are none, so this time in the left side of this ANS means one traversal is over and ANS holds 124. Again, since we will move in a recursion. So we will go back here. Let's see, use it another color. So from here, we will go back to this 2. So at this time, answer holds 12. So in memory, answer already holds 124 for left. Now it is moving on right side of left. So this time answer has 12 currently as it's a recursion, and it goes on right side and again call this line, implement this line. So it will store 5 as 125. So we can see that we have traversed the whole left tree. So in left tree, the answer would be stored something like this: 124 plus, and the right of this left tree holds 125 and left holds 124. So they both get sum up and it will store as an answer in left tree of this whole tree. So the output will be 125 plus 124. So the sum would be like this: 249. So means root dot left holds 249. Now we will traverse the right side. Since it's a recursion, it will go back to this root node, and from here it will go to right, and from right it will go to left. So forms the number 139. It goes same like that we did in left side. Answer holds 139. Then it will go back to this 3, and from this 3 it will go to 7. So the number will be formed 137. Sorry, it is 136 in place of 9. It's my mistake. Okay, let's put it on charging. Okay. So as we have discussed, it will go to 7. So forms the number 137. So we can see over here that the left side, as we have discussed, that first it go to left, then the right of left holds 125. Similarly, the right, we are moving to this right tree, and its left part hold 139 and its right part hold 137. So they both get sum up and holds as an answer of root of right tree. So now this is root of right and this is root of left. So they both get sum up and returns the final output. I hope that the logic is clear to you all. So now came to coding part. So since we have given only with root, in recursion we also one variable answer. So we will take another method. Yeah, and in Python, we can also declare the function inside this method also. But just for clarity, I'm taking it as another method. So def, suppose I'm taking solve, or we take solution, and in that we are taking self, comma, root, comma, answer. So as we have discussed earlier, so firstly, if root equals to, sorry, none, then we will return 0. Why 0? Because here we are doing summation. If we return none over here, then it will generate compatibility error. That's why we are returning 0. And in summation, if we do summation of 0 in any value, it will not affect our answer. So answer equals to answer into 10 plus root dot 12. Okay, now we will check for boundary condition, that if root dot left equals to none and root dot right equals to none. In that case, we will return the answer. Return answer. If not, then we will call the recursion return. First, we will call the left part self dot solution root dot left comma answer would be same. Okay, let's now summation of. Now we are summing up of the right side also, self dot solution root dot right comma answer. So our logic parts gets end that we have discussed previous. Okay, now it's time to call this method that we have created for the. So let's take answer equals to self dot solution passing root comma 0. Initially the value of answer over here is 0. So we catch this answer in this variable answer, and finally we will return it. Return answer. So let's run it. Okay, the sample test gets passed. So after submitting it, so you can see over here that the solution runs completely fine. So this is our solution. Let's discuss the logic once again. We will check that if this is our base condition, if root equals to none, then we will return 0. And it is our answer calculating that answer equals to answer into 10 plus root dot 12 for just adding the value. And if this is our boundary condition, that if root dot left equals to none and root dot right equals to none, then we will return answer. And finally, we are here calling the method again for recursion. First, we will call left and then right. We already discussed the logic that how this recursion works. So let's see the C++ solution also. I had already written that. So it is exactly same that we have discussed. Here just the change in method and variable is there. So we can change it, no problem. So I'm taking solution tree node root comma answer. If root is null, then answer equals to answer answer into root dot left return answer. In place of solve, we are writing as solution section. So here also we will call solution. So no need to change this. Here we can take state. Yeah. So I hope that the solution. Let's run it. Okay, here we have not changed once. Let's change here also. Okay, the sample test gets passed. Now submit it. Okay, the solution runs at 0 microsecond. Well, it happens rarely that this thing happens. Generally, it don't happen. And no wonder why, because C++ runs much more faster as compared to other languages like Python. So that's why maybe it happens. So let's check the solution. As we can see over here, that solution is 100% fine. So the solution is like as it is completely same as we have discussed earlier. So just there is a change in difference. This is our base condition that if root equals to null, then we will return 0. Same answer equals to answer into 10 plus root of well. In place of dot, we are using this. So same boundary condition. If root of left equals to null and root of right also null, then this is our leaf node. So at this point we will return the answer, means we will reach the value that we have to submit. So otherwise we just call the recursion solution root of left and root of right. I hope that the logic is clear to you all, and the solution also clear to you all in both Python and C++. I hope that you all were able to match it. So whosoever comfortable in any languages like in Python or C++, then you can do it in any language. And if you want any solution in any other language like Java, Ruby or something else, then you can comment us. We will look after it also. So thank you for watching. We will meet again with a new problem of TSA. Till then, keep learning.